Okay, so today we're just continuing on with section 5.5 of the book. Um, First thing we'll talk about is the factor theorem. What the factor theorem basically says is if the remainder is equal to 0 when you divide, so if the remainder is equal to 0, then the divisor is a factor of the polynomial that you were dividing. The divisor is a factor of the polynomial.
Does that mean like it factors in completely?
Mm-hmm. Like there's no remainder. So just like when you do 3 divided into 24, it goes in exactly 8 times and there's no remainder, right? Well, 3 and 8 are factors of 24. So it's the same idea with polynomials. If you have a remainder of 0, then that is a factor of your polynomial. So let's take a look at example 5 here. We've got f of x equals 3x cubed minus 4x squared minus 28x minus 16. And we're given that x plus 2 is a factor. So if I do x plus 2, if I use the 2, x plus 2 in synthetic division, I should be able to factor what's left over and fully factor the whole expression. So first of all, I'll bring down my coefficients. So I've got a 3, a negative 4, negative 28, negative 16. And then since it's x plus 2, negative 2 is what x would equal if we were setting it equal to 0. And I bring down the 3. 3 times negative 2 is negative 6. Add those together, I get negative 10. Negative 2 times negative 10 gives me positive 20. I add those together, I get negative 8. And then negative 2 times negative 8 gives me positive 16. And I have a remainder of 0. So that means that x plus 2 went into it perfectly evenly. All right, so I know x plus 2 is one of my factors, and then right now I have 3x squared minus 10x minus 8 that I got from the synthetic division. Did everybody follow where this came from? From these down here, okay? All right, so now I can just factor what's left. So I've still got the x plus 2, and then I'm going to factor the 3x squared minus 10x minus 8. So 3 is a prime number, so the only way I could get 3x squared is if it was 3x times x. And then 8 could be 4 times 2 or 8 times 1. And since I want it to come out to negative 10, I'm going to put the 4 over here and have that be negative, and then put this plus 2. And so the fully factored form for that polynomial would be f of x equals, I guess I should have an f of x out in front of it. Let's move it over a little. Oh no, they're all in pieces. Moving it over did not work out very well, did it? All right, there we go. All right, now it's fully factored. So f of x would equal x plus 2 times 3x plus 2 times x minus 4. Does that make sense, what I did? We're using synthetic division to get it down to something that's easy to factor. All right, so let's take a look at this one. We've got f of x equals x cubed minus 6x squared plus 5x plus 12. And x minus 4 is a factor. Am I missing any coefficients? No, I'm not. So I've got 1, negative 6, 5, and 12. And I put a positive 4 on the outside. All right, you guys go ahead and do the synthetic division. If you would like to do it on your whiteboard, you can do it on your whiteboard. So what do we get from the synthetic division? You brought down the 1, right? Okay, and then we did the 4, and we got negative 2. Okay, so what is the extra, what's the trinomial that you're having to factor now?
X squared minus 2x.
Right. All right, so the final answer then would be that f of x is equal to x minus 4 times x minus 3 times x plus 1. Any questions on that? Are we comfortable with that?
Yeah.
Do we want to do one more? Yes, no, maybe. How many want to do one more? All right, we have time. I'm gonna let you guys do one more. All right, let's do this one. You can do it. This shouldn't take long. This should take a lot less time than the last one. Because now you're getting the hang of it, right? It is a lot easier than long division, yes. Long division. Okay, I think we're all agreeing it's x minus 4 times x plus 5 times x minus 2. Any questions? All right, so the other thing we're going to look at is finding the zeros. Okay, so one of the zeros of f of x equals x cubed minus 2x squared minus 23, oh, not 1, 0, but, oh yeah, okay, yeah, is x equal to 3. So if x equals 3, that's one of the zeros. So when we're finding the zeros, we're just factoring and then setting each of the factors equal to 0. So we're just using the zero product property to find the roots after it's factored. So this is just taking it one step further than what we just did. Okay? All right, so if x equals 3 is one of my zeros, I'll put the 3 on the outside. And then I put my coefficients in here, so 1, negative 2, negative 23, and 60. Okay, so 3 times 1 is 3. Add those together, I get 1. So we have a 3 again. And I get negative 20 times 3 is negative 60. I have my remainder of 0. So f of x is equaling the x minus 3 and x squared plus x minus 20. And we want to find the zeros, so actually we're going to set it equal to 0. And so 5 times 4 is going to give me 20, so the 5 has to be positive and the 4 has to be negative in order to come out to a plus x in the middle. So that means that x minus 3 equals 0. That's the one they already gave us. X is 3. X plus 5 equals 0, so x could equal negative 5. And then x minus 4 equals 0, so x equals 4. So if I want all the zeros, it's negative 5, 3, and 4 are the zeros of the function. So you guys see I just took it one step further, right? Okay. All right, so let's find the other zeros of this given that f of negative 2 equals 0. So what's one of our zeros already that we have? Negative 2. So what goes on the outside? Negative 2. All right, go ahead and do that. And find the other zeros.
Did you watch the movies? American Pie.
Okay, so I think we're all getting the same answer. We end up with x squared minus 9, and so it's plus or minus 3 are the other two zeros. So negative 3, negative 2, and 3 are all the zeros. All right, just to make sure you guys got this down. One more. All right, I think we're all agreeing on this one. You end up getting x squared plus 6x minus 7, which factors to x plus 7 times x minus 1. So your zeros are negative 7, negative 2, and 1. All right, so any questions? All right, what if it tells you to find the roots? Are you going to know what to do? What are the roots? The zeros. What if it tells you, it gives it to you with just a 0 already there, and it tells you to solve the equation? Then what are you going to do? You do the same thing. You're solving for the zeros, okay? So your solutions, your zeros, your roots, your x-intercepts. Oh, what if it tells you to find the x-intercepts? Same thing, okay? All right. Good.